Use substitution to solve the system. Remember, the word system means more than one. In other words, this is a system of equations. So there's more than one equation. And we already noticed that x is isolated in one of the equations. Let's call the first equation, equation 1, and then the second equation, equation 2. We're going to substitute 1 into 2. Sub 1 into equation 2. So whenever we see an x, we are going to put parentheses 3y minus 8. So take your equation 2. Whenever you see an x, you're going to put parentheses 3y minus 8. And then we're just going to add 2y is equal to 27. Now you could react to this problem and solve for y. This is negative 15y plus 40 plus 2y is equal to 27. So negative 13y is equal to negative 13. Negative 13 is not 0, so we could divide both sides of the equation by negative 13. Y is equal to 1, but you're not done. Now we're going to go back to equation 1 and try to get x. Remember, x is what? X is equal to 3 times y. So whenever we see a y, we put parentheses 1 and then minus 8. So x is negative 5. What does this mean? That means our solution set is a unique ordered pair. We have a set that consists of a unique solution, which is called negative 5, 1. Geometrically, these two straight lines intersect at negative 5, 1. So this is called a what? Is a set consisting a unique solution to the system. Consisting, meaning it consists a solution. In this case, a unique solution. Let's solve the following system of linear equations. We have 9x plus 5y equals negative 1. We also have negative 7x plus 8y equals negative 23. Since neither one of the variables are isolated, we're going to use the addition method instead. Some texts will call it the elimination method. I like to call it the addition method because we simply add in mathematics. And what are we going to do? We're going to do a little bit of trickery here. Why don't we temporarily eliminate the x values? And the way we're going to do that is find the LCM of 9 and 7. What is the LCM of 9 and 7? Both of these are relatively prime, so in this case we can multiply them together to get 63. And notice 9 is simply 3 times 3, and 7 doesn't have any factors of 3. 7 is just 7. 7 is a prime number already. So if we multiply them together, we get the LCM, which is 63. We're going to take this 63. We're going to use it. So what I'm going to first do is label this equation 1 and equation 2. And now we're going to do 7 times equation 1. 7 times equation 1. And I'm going to put it right here. And then we're also going to do 9 times equation 2, which I'm going to put right here. Now, what does it mean to have 7 times equation 1? Just off to the side here, I'm going to just briefly talk about what is my notation saying. 7 times equation 1 is really 7 times 9x plus 5y is equal to 7 times negative 1. And so that's what I mean by 7 times equation 1. Now I'm going to write it over here. I'm going to write it as 63x plus 35y is equal to negative 7. Now I'm going to do 9 times equation 2, so we get negative 63x plus 72y is equal to 9 times 23, let's see, 207. So we get negative 207. And now we're going to do the addition method. And we're going to add both these equations in a vertical fashion. So we get 0 times x right here. There's 0 times x. I'm not going to even write it. Now over here we have 107. So we get this new equation that says 107 times y is equal to negative 214. 107 is not 0, so we're going to divide the entire size by 107, and we get y is equal to negative 2. Now, we're not done yet, so we got to get x. How should we get x? A couple different ways to do it. I would probably pick on the equation with smaller numbers. So why don't we pick on equation 1? I'm going to pick on equation 1 and try to solve for x. So we are going to get negative 1 minus 5y divided by 9 is equal to x. And we already know y is negative 2, so x is equal to negative 1 minus 5 times negative 2 over 9. So x is equal to, looks like 9 over 9, which is just 1. So our final answer is a set consisting a unique solution. And our unique solution is an ordered pair, 1 comma negative 2. There it is, you're done. That is a set consisting a unique solution. So our system is consistent. Let's solve the following system of linear equations. 5 6x minus 1/3 y is equal to negative 3. Negative 1/5 x plus 1/2 y is equal to negative 6. Now geometrically, these are two straight lines. And two straight lines could do three things. They either intersect, or they're parallel to each other, or one is on top of the other, meaning they're actually the same line. Well, let's find out what this is using some algebra. Why don't we clear fractions? Well, before we even clear fractions, let's label this equation 1 and equation 2. Now I'm going to attempt to clear fractions. What is the LCM of 3 and 6 and 1? 3, 6, and 1. That would just be 6. So we're going to multiply both sides by the LCM of 3, 6, and 1, which is 6. The LCM is 6. And we're going to write a new equation after that. Why don't we write it over here? Let's write this new equation. It's simply 5 times x minus 2y is equal to negative 18. Equation 2, what is the LCM of 5, 2, and 1? That is 10. So let's multiply the entire sides of the equation by 10. And we'll get another equation. We'll get negative 2x plus 5y is equal to negative 60. And now you could either use a substitution method or the addition method. I'm actually going to use, let's try to use the addition method here. Why don't we temporarily eliminate the y's? So this is equation 3 now, and this is equation 4. What I want to do is go 5 times equation 3. I'm going to do 5 times equation 3. And then I'm going to do 2 times equation 4. 2 times equation 4. What does 5 times equation 3 mean? What I mean by that is I'm simply going to multiply both sides by 5. And so I would do this by 5 times what? Negative 18. And where am I picking 5 from? I'm looking at the LCM of 2 and 5, which is 10. So I'm trying to create a 10. I'm trying to get a 10 to show up in a nice position. Let's do 5 times equation 3. We get 25x minus 10 times y is equal to, 90? Yeah, it's 90. Negative 90. And then 2 times equation 4. So we get negative 4x plus 10y. There it is. There's those 10s with opposite signs. That's going to be very, very convenient. And then negative 120. Now I'm going to do the addition method. The addition method says add the two equations vertically, and we get 21x now. 21 times x is now equal to negative 210. Ah, beautiful. 21 is not 0. Divide the entire sides by 21, and we get x to be negative 10. Now we got to find y. Where are we going to find y? There's so many choices. Now, why don't we pick on equation 4? Let's pick on equation 4 to find y. So solving for y there, we get y to equal 2x minus 60 divided by 5. And now we just simply substitute our x. 2 times negative 10 minus 60 all over 5. So that is negative 20 minus 60 is negative 80. And then how many nickels are there in 80 cents? There are 16 of them. So y is equal to negative 16. Our final answer, this is a set consisting a unique ordered pair. And that ordered pair is negative 10, negative 16. So in our case, these lines actually intersect at the ordered pair, negative 10, negative 16. Let's solve this system of linear equations. Notice there are decimals here, and the first equation has decimals of only one decimal place to the 10th. And so in order to get rid of the 10th, the idea here is, remember that we could say, 1/10 times 10 gets you an integer called 1. So that is sort of the idea here. But we want to balance the equations. And, well, we got to do one equation at a time. So why don't we call the first equation, equation 1, and the second equation, equation 2. And we're going to do 10 times equation 1. And if you do 10 times equation 1, that really just means multiply both sides by 10. So you multiply both sides by 10. Something happens to that decimal. You basically create that decimal and turn it into an integer. So 10 times equation 1, we get negative 2x plus 4y is equal to 2. Now, the second equation has two decimal places. So instead of using a 10, we're going to use 100. That way we balance that equation and still have integers in the end with this new equation. So this is 3x plus 16y is equal to negative 69. Now I tend to like the addition method. I am going to rename these equations. I'm going to call this equation, I don't know, let's call it equation 5. No, why am I calling it equation 5? Why don't we call it equation 4? And let's call this equation 5. I am going to use the addition method. So I'm going to do negative 4 times equation 4. And then I'm going to simply put equation 5 underneath it. So I'm going to put a 5 right here. What's negative 4 times equation 4? And then what's equation 5? Let's find out. Let's see. 8x minus 16y is equal to negative 8. And then 3x plus 16y is equal to negative 69. Now we're going to do the addition method. So we're going to add vertically. And we get 11x is equal to negative 77. And then x is equal to negative 7. And we go back and find y. Pick a convenient equation. I would probably pick equation 4. If you pick equation 4, we get y to be what? y to be 2x plus 2 over 4. So y is equal to 2x plus 1 over 4. So we have y is equal to x plus 1 over 2. X is negative 7, so if you plug in x to be negative 7, that is negative 3. Negative 6 divided by 2 is simply negative 3. So we have a set consisting a unique solution, and that unique solution is a unique ordered pair. And so that is our solution set to the system of equations. Why don't we circle that? Why don't we solve these two systems of equations and see what happens? The first equation, the first system, conveniently, we have a lot of opposing signs. So why don't we apply the addition method to this? If we apply the addition method to this, we get 0 is equal to 0, which is a true equation. This is true for what? For many values of x and y. Right? 0 equals true. 0 equals 0 is a true equation. We already know that. So how do we write our solution set? Our solution set then would be, it's the set of all ordered pairs such that, you could pick either equation. I'm going to pick the second one. Negative x plus 4y is equal to 4. And you're done. That is our solution set. So how many solutions are there? There's infinitely many. Now, geometrically, what do these mean? These are two lines. However, one is on top of the other. In other words, these are two equations representing the same geometric line. But there is more than one way to write this line. So that's why we still say mathematically, these are two lines, but one is on top of the other. So we really have an infinite number of solutions with a certain property. Now, keep in mind, how do we read this vertical bar in the set builder notation? This is read as such that. Let's solve the second system and see what happens. The second system here, if you let's rename this. Let's call this equation 1, call this equation 2. I'm going to rewrite equation 2. I'm going to rewrite that to be negative x plus 3y is equal to 6. And let's call that equation 3. Now I'm going to do equation 1. I'm just going to list that. And I'm going to write equation 3, which is negative x plus 3y is equal to 6. Now let's apply the addition method to this. Add vertically. And we get 0 is equal to 12. Now is that true? Absolutely not. This is false. In other words, when you get this kind of logic, when you do all the correct algebra steps, using the correct properties of real numbers within an equation, and you get a false equation, that means there's going to be no solution. So the set of solutions here would be empty. So we actually say there's no solution here, or the set of solutions here would be empty. So if you really, really wanted to get fancy, you could take the set notation and leave it empty. I'm sorry, my second set brace is not as pretty as the first one, so let me slow things down and make it prettier. Let's write this set brace there. And there's an empty set, and you could actually write that. I would actually accept this as the meaning for no solution. Two mechanics worked on a car. The first mechanic charged $115 per hour, and the second mechanic charged $85 per hour. The mechanics worked for a combined total of 15 hours, and together they charged a total of $1,575. How long did each mechanic work? The first thing you want to do in any word problem is translate the words into a mathematical symbol. So we got to take some of these words and actually translate it into a mathematical symbol. In many cases, we call that a variable. Let's translate some of this. Let's say the number of hours that the first mechanic worked is F. Now once you get one of the translations, it's much easier to get the second one. So why don't we just do this? Number of hours that the second mechanic worked is capital S. This is getting good. And if you've forgotten what the word problem says, just make sure you go back and read it again. The mechanics worked for a combined total of 15 hours. Now, F represents hours and S represents hours, right? They're both number of hours. So we could put F plus S must be what? F plus S. Equation 1, F plus S is equal to 15. So this is an hours equation. And what is equation 2? We're trying to get a system of equations here. Well, the second equation is going to be the money equation, right? It's going to be the dollars equation. So each equation actually has units on it. The first mechanic charged $115, and the second one charged $85. And the total amount charged was $1,575. So this is a dollars equation. It's also the money equation. And then, of course, from here on out, you could solve this any way you wish, whatever suits you the best. I typically like the addition method, so I'm actually going to do negative 85 times equation 1 and actually rewrite this. And then I'm just going to rewrite equation 2 right here. I think the hardest part of solving systems of equations is trying to stay neat. So I said negative 85. So this is negative 85F minus 85 times S is now equal to 1,275, but negative, right? Negative. Now we're going to apply the addition method. Go ahead and add here. And what do we have? We have 30. Yeah, we have 30 F's. 0 S's. And then we have 300. Whoa. 30 is not 0, so we can divide the equation by 30. And F is equal to 10. How long did each mechanic work? We also need this S. Well, S has to be 5. It's pretty clear by equation 1. Go back and look at equation 1, and you get S. Let's answer this question in a complete sentence. The first mechanic worked 10 hours, and the second mechanic worked 5 hours. It's very important to actually answer in a complete sentence because it validates your thinking and it validates your labeling of hours. There they are. Make sure you label hours and hours. Okay. There we go. 2 trains leave towns 930 miles apart at the same time and travel toward each other. One train travels 12 miles per hour faster than the other. If they meet in 5 hours, what is the rate of each train? I'm going to draw a picture, and typically in science, when we try to draw 2 masses, we're going to draw them as little dots. I'm going to draw the faster train as the first dot. Let's call this the faster train. And it's going to travel faster than what? The slower train. Let's put the slower train over here. And I really don't know if it's on the right or on the left. It doesn't really matter. But I do know that the faster train has a higher speed. So I'm going to draw an arrow here indicating that it has more speed. And the slower train has less speed. And I'm going to draw a shorter arrow to indicate less speed. Well, let's say the slower train has the speed of r, or the rate r. And then the faster train would simply be what? R plus 12, because it's 12 miles per hour faster. Now we're going to take this visual and put it into a table. And let's label the table like this. I'm going to put faster train description, and then a slower train description. And our classic relationship here is distance is equal to rate times time. And that's the kind of information we're going to organize. So we have the rate of the slower train, which is r, and the rate of the faster train, which is r plus 12. We also know the total time traveled. They're both going 5 hours. Both trains are going to travel 5 hours. The thing that we don't know is the two different distances. They're different, so I'm going to label them d sub 1 and d sub 2. We do know something up here, though. We do know they're 930 miles apart. In other words, we're given the total distance. d1 plus d2 has to equal 930. And that's sort of the breakthrough there. We also have a substitution now for d1. d1 is simply 5 times r plus 12. That's d1. And then what is d2? d2 is 5 times r. Because rate times time gives you that distance. Is now equal to 930. Now we just react to the problem and solve an equation. And so we have 10r plus 60 is equal to 930. Subtract 60 from the entire sides. We have 10r is now equal to 870. 10 is not 0, so divide the entire sides by 10. R is equal to 87. And now we're ready to answer the question. The slower train is traveling, or let's say has a rate. How about that? We'll keep it simple. The slower train has a rate of 87 miles per hour. And the faster train has a rate, of 99 miles per hour. Circle our final answer. Make sure you show your work. And make sure you write the units next to your numbers. A motorboat travels 280 kilometers in 5 hours going upstream. Let's draw that as scenario 1. Scenario 1 is actually a stream, and that's going upstream. If it's going upstream, it's going to be going a lot slower because it's going against the current. And what would scenario 2 look like? A motorboat travels 280 kilometers in 5 hours going upstream and 728 kilometers in 7 hours going downstream. So scenario 2 is downstream. So this is upstream. This is downstream. If it's going downstream, and let's say this is your boat's actually a little dot, then this arrow going downstream has to be bigger. You know, how much bigger? If this arrow was just the speed of the boat, and then the speed of the boat arrow would be identical over here, but then what would the current be? Well, why don't we put the current as another arrow, and it's probably not as big as the black arrow. So why don't I draw this shorter? You never know though, there could be some really, really strong currents, but maybe it's just a little bit more like that. So that's the two scenarios. Now, our goal is to collect some of this data and put it in a table as well. Why don't we give it 4 columns and 2 rows. So the motorboat going upstream. Then we also have the motorboat going downstream. It's all about the motorboat. What's our classic relationship here? Distance is equal to rate times time. And let's collect all the information, put it in a nice little table, organize it, and find what we're missing. We have 5 hours going upstream, 280 kilometers, and motorboat going downstream, we have 728 kilometers, and in 7 hours. What is the rate of the boat in still water, and what is the rate of the current? Why don't we use little b here for the rate of the boat? And the speed here is also little b. And then why don't we use little c for the rate of the current? So going downstream, we actually have b plus c. Going downstream, we have b plus c, and that's easier to see. Now going upstream is a little bit tricky, but it's got to be, the current has to be in the opposite direction of b. So we're going to say b minus c. Opposite direction of b. So we got to say b minus c. Certainly wouldn't be b plus c because that's already downstream. The other thing you got to realize is the current is not faster than the boat. So it's got to be 0 is less than c, less than b. The boat has to be traveling faster than the current. All right, we're ready to solve this. It says, what is the rate of the current? We actually want to find the rate of the current. But our equations right now look like they're ready to be solved for b. So it doesn't hurt to solve for b and then go back and solve for c. Oh, I actually asked for what is the rate of the boat in still water and what is the rate of the current. So we're going to need both anyway. Let's get them. Equation 1, 280 is equal to 5b minus 5 times c. And equation 2, 728 is equal to 7 times b plus 7 times c. I am going to do 1/5 of equation 1. So do 1/5 times equation 1. And we get, let's see, what's 280 divided by 5? That's 56. So we get 56 is equal to b minus c. Let's do 728 divided by 7. Is that? Yeah, it is. So let's do 1/7 times equation 2. And we get 104 is equal to b plus c. And I'm going to apply the addition method to these two new equations. We're going to go ahead and add vertically. So we get 160 is now equal to 2 times b. So b is equal to 80. And now we have to find c. Not a problem. To get c, it will just be b, just take this equation here to get c. C is equal to 104 minus b. So c is equal to 104 minus 80. So that would be 24. C is 24. So the rate of the current is definitely less than the rate of the boat. Why don't we answer the question in a complete sentence? The rate of the boat in still water is 80, kilometers per hour. And the rate of the current is 24 kilometers per hour. Pretty fast. So make sure you remember to write your units next to your number. Typically, if you're given a problem using words and sentences, you should answer it back using words and sentences.